He's had a lot to say on various books and standards. Ladies and gentlemen, please welcome Constantinos Balaras.
Thank you. Thank you very much. This is an opportunity when we have a technical conference to switch from one topic to another. And the presentation I'm going to be making is based on a paper we have presented and will be included in the proceedings on a very specific topic. So we're going to be narrowing down to an issue of how, in the process of doing assessments and calculations, we evaluate the impact of one of the key parameters in terms of really predicting the performance of a building based on weather data. The work we presented in this paper is based on an MS thesis and by Mr. Stefanakis. And we tried to really assess part of what we call the big picture. When we're dealing with new buildings in terms of design, well, life can be a little bit easier because we are setting up the stage, we are really setting up the problem, and if we get it on the right track from the beginning, things will be easier for us and for our clients. We heard from Tom the way to address several of the issues with regard to the building. It becomes a lot more challenging when we're talking about existing buildings. And especially it becomes an issue when, as we've heard quite clearly, the message about the role of us in the building, the occupant, and how we actually drive and operate the building. Altogether, all these big areas, issues, topics, we can handle most of the time with great accuracy with our tools, whether that would be a simulation, very accurate calculation, or simplified methods. Altogether, we have the right tools in order to assess the needs, the demand, in order to assess the actual energy use, in order, for example, to issue an energy performance certificate, a label. So, taking into account all these issues, when we narrow it down to what you do in your country, in Greece, to handle this basic needs in terms of our calculations, we have a national calculation tool. So the work that we have been doing in this area is narrowed down on our national tool. Now, of course, you say, well, how does that apply mine? You will have, probably if you come from other countries, your own tools. The inputs that address all these different parameters in Greece for the specific need of labeling our buildings are, to a great extent, predefined in the regulation. We call it, the key word here is cannot, and a series of guidelines that provide the input, the information of minimizing the need as a user of the assumptions, the risk of doing mistakes. So they narrow down and try to keep you focused as a user to specifics that we have as input driving our calculation tool. Probably, again, you keep thinking of your own situation, wherever you're coming from, in terms of how that fits with what you're doing, probably something similar to that in your own country. So that's the situation we have. A specific tool with specific, for most of these parameters, input that are prescribed in the technical guideline according to the regulation. What really is driving this interest now is coming or trying to address some basic questions that, as a user, as a professional, no matter where you are, you probably have been challenged with or in the background of your mind. So what's really setting the stage for this is that, yes, we have to keep in mind, we are using a specific tool in our case. We are also need to keep in mind that this is not a full-blown simulation tool. It's rather prescribed in order to assess and give a label to your building in this effort of ranking and assessing our buildings. But most of the times, especially when we're dealing with existing buildings, we're going to perform an energy audit. We're collecting input. Don't tell me you haven't wondered, collecting the input, how accurate is this input? How easy it is to identify and provide the necessary information to drive your tool. How concerned would you be by looking at an existing wall construction to extract from that the U value? How concerned you are when you're looking at a boiler, even if it has a certificate, how accurate now or how up to date is this information for a certificate that was issued last heating season? Or if you go at the end of the heating season that was issued at the beginning. There are always questions of how much emphasis and effort should I put in trying to identify all this information. And when you do, you wonder, now, God, how would that affect my result if it wasn't exactly that number for the U value, if it wasn't exactly that number for the thermal efficiency? And of course, we all understand, I'm not going to go into details, for example, talking about thermal efficiency, you know, depending on the operating conditions, this changes. So, unless you have a dynamic model that actually has the information of how to describe the variability of the thermal efficiency of the different operating conditions, you're never going to be close. But then you say, well, how much difference would that make on my results? Then you wait, do I have enough information from my unique building? Because my building is unique. It's the one I'm working on. And then, for example, with regard to the weather data, you say, well, I have weather data even for the greater area city that I'm at best. Would that be appropriate to use? For example, weather data from an airport within the city? That's a basic, always question. A lot of work that's been done to really transpose and expand or adopt information, weather data from an airport to the complexity of the weather data in a neighborhood within the city and so forth. But keeping it simple and back to our main issue topic here with the specific tool, with the specific situation is that how much or would I need more information to include for more locations, for more weather data? Questions like that compared to then if I had that information in greater detail, how sensitive, what difference would it make to my results? So, with regard to the weather data, because it was obvious from the topic that we're going to be focusing on this, would I be able, at least for a first estimate, a first assessment, to use an average weather data that would be representative regardless of the exact location? That would be possible then to simplify the work and do a first assessment easier. All these questions, issues, kind of like provide the background, the motivation of this work. What is not, though, I can tell you with a single word, what is not that we're not trying to do is to validate the tool. The tool exists, the tool it is. So we're not trying to test it because, by the way, there are standard ways that you can test a software. It's the best test from FASHRAE's previous work that you can validate a tool. That is also now an European and ISO standard. So we do have all that. We're not trying to replicate that. That was done at the earliest stages of development of our national software. So we are concerned with the practical issue from all these different parameters to look now at this one area we're focusing on in this work with the weather data. To do that, we need an example building. We need something to test drive, to use it with our tool. So we consider a couple of different types, well, one type of building, but with a little bit differentiating in terms of the construction. It's a single family house, so we take that. And, well, we set it up to comply with the previous thermal insulation code in terms of its envelope that we had back in the 80s. And since we are talking about the interaction of the building with the outdoor and the indoor in this energy performance analysis, what we say, well, what about if the boundary of the building was a little bit different, better thermal protection according to our more recent code, which is stricter than the previous one, just to have a differentiation. But we're talking about a single family house. What are we providing as inputs to the tool are the weather data that we have from the specific guidelines for 62 locations in Greece. So the weather data is prescribed, is defined, and we provide that as the input, and then we want to see what happens with the output. Just to give you an idea, the dots here present the locations of the weather, of the standardized weather data that we have for our calculations in Greece. Probably you're using some kind of weather data in your location. FASHRAE provides weather data for international locations. So we have various resources. In Greece, we have to use in this kind of work, this specific weather data. From these 62 locations, you notice the country is split down in 4 weather zones. This split down in definition was actually done before the new regulation. That's what I call here pre-KENAC. KENAC is the national regulation code. So before that, the country was split down to and defined to 4 climate zones, and the various cities then in the different zones are identified here. Using that information, then we try to get 4 weather data files in addition to the standardized that include the average conditions for each zone. So for each one of the 4 zones, we generated from the available specific weather data for the locations, 1 average weather data. So the idea there, keep in mind, was what kind of results would I get if instead of knowing different locations using different weather data in this climate zone, I use, for example, this is climate zone A, southern Greece, the warm and milder zone. I use 1 weather data, 5 for the average conditions in the zone. What kind of variations from doing this exercise and repeating this exercise, looking at results, would get? Can I simplify my calculations for a first assessment, not to do what the code requires in terms of the certificate, generating the certificate, but for a first quick assessment, use an example building that is similar to my building, use an average weather data, doesn't really make much of a difference, or does it? Depending on what locations I have in that weather zone. And of course, we do recognize, we have to emphasize this, that I don't want to be misunderstood, that no one single parameter is going to really describe the complex and coupled phenomena of the dynamics that the building has in terms of its operation with the outdoor environment or what's happening inside. But in terms and tailored to the approach that we're using, we're trying to see these impacts and to quantify and look at the results and understand what's happening. We're using the heating degree days and the cooling degree hours are indicators of the winter weather conditions and the summer weather conditions, so that we can at least have a better understanding if we get higher energy demand for heating in areas that they have higher heating degree days, that's a logical result. That's what we expect. That's what we'd like to see. So we calculate our EUIs. We heard before the definition, the energy use intensity, the area normalized by the unit floor area so that we know how big or how small it is. And we do the calculations for the heating. We do the calculations for the cooling. We do it for our first example building, the single family house before the new building code, which means less thermal insulation. So we expect more heating losses, higher heating demand, higher heating energy use. And with the new code, which is better thermally protected, so everything is lower as we would expect. What we see using the zone average weather data file, so we have 4 points for the 4 zones. The mild southern Greece, of course, has the lower energy use. To the colder, we see and we get the result of what we would expect. So you say, yeah, that's reasonable. So instead of using all the different locations of the weather data, we can use this and we get a trend. Well, let's see now if we put now the information from all the 62 locations and argue whether I place my building correctly and it would fall within that and expect some kind of differentiation. So I put all my results now in that group of, and every point here represents one weather data for a specific location in one of the 62 locations in Greece. The mild southern part of Greece, the more harsh conditions up in the north, and I look again at my results, both in terms of using and getting the means and looking at the variance with the specific 62 weather files for each zone, looking at the average weather file here that I used. And first observation is, for example, using the average weather data. For the zone A, I get about 98.5 kilowatt hours per square meter primary energy use. Using and looking at the mean and the standard deviation for zone A using all the locations, you see you are in the ballpark. So, and we see that in the clouds here of the average big points using the average data and then the specific locations. Now, though, something interesting that came up was to start a little bit focusing on what's happening. And we see some mixing. We see and we notice that some strange things are happening. You expect, because here we are having the heating degree days. So higher heating degree days mean harsh winter conditions, more heating is necessary and so forth, you would expect. And so the northern part of the country is colder up there. You see this green points, and then you see there's one more location that has actually milder overall together, but is assigned to that zone. You also see from the southern end, they expand and they overlap a few of the points, and some of this information is specified in this notes there. You see that there's also some of them extending and getting and mixing with the different climate zones. That is an indication that we probably need to look back again on how this distribution of the different locations within the different climate zones have been defined in the earlier times before our regulation, before CANAC, to see how this is actually, or could actually improve the distribution in terms of grouping and having the locations in a more organized fashion. And I try to minimize this mixing that creates, of course, a problem, because that has implications on the code, on the demand and the specifications of the code in terms of the construction and performance. Another way we try to really group this data, this information, so that one in the future, can identify and look at these variations when we put everything together, the primary energy demand, the total primary energy demand, both in terms of the heating and the cooling needs, to see, looking at its annual performance, if there are any variations, major variations, and we look at the 3 climate zones, because the 4th one doesn't have enough information only for one location for the cooling, so we didn't include it here. But to look at the valleys and the peaks in the areas where, combining the summer and winter conditions together, you see a differentiation from what the rest of the locations are doing within this climate zone. Presumably, these peaks and valleys can then help you to say, if tomorrow we decide to add more information, to collect more weather data, and make it available for the users to use, these are the areas where we need to investigate whether we can populate a little bit better our weather data. So in conclusion, it appears that, at least for the simplification first step, that one would like to make some quick calculations, not really replacing the demand of what the code says that you have to comply with. That's a different story. But in the first assessment, because we have already, to give you some background, we have already tried to develop a simplified tool for building occupants, users, or for a consulting engineer that quickly, in a matter of just a few minutes, using typical example buildings with typical information to make a first assessment of where at least is the starting point for his building that he will investigate, or he will investigate later on with accuracy. It seems that using this average weather data can give you, it's within what you would expect as the overall trend. It also resulted that we may need to revisit this allocation distribution of the cities and the associated weather data in our definition of the climate zone boundaries. Now, of course, we're scratching the surface here because there's a lot more work that needs to be done, because we noticed and we reviewed there's a whole big number of different parameters that not only individually, but coupled together. Now we're getting into the dynamics of the problem, that we realize the complexities of these issues, of other input data that we as users, especially for existing buildings, are being called on to specify and provide input to our tool. U-values, thermal system efficiencies, and so forth are the additional parameters that we would like to investigate in a similar fashion. We are again not trying to validate the tool, but to really use this knowledge in order to support these simplifications from a practical point of view in terms of the specific tool and what kind of results we can get in order to simplify the overall approach. Now, I have never experienced, Mr. Chairman, a chair that would actually cut my voice off to finish, but I guess you have done that, so I'm done. Thank you very much for your attention.